Hello guys, long time no see, 6 months without a video, and here I am back. So welcome to all the new viewers, and also hi to all the olds. And basically today I want to cover something that is not really covered well on the internet, and it's something that I've been doing throughout the 6 months. So one of the projects that I've been involved into was to do with HIPAA-compliant deployments for a medical application. Well, HIPAA, I think you already know it, but it's an American standard for data protection for medical and financial applications. And the whole point of it is that it needs to be very encrypted, very secure, everything needs to be private. And it's pretty complex, and not many platforms offer this kind of deployments. So before, I've been very familiar with stuff like Railway, Vercel, DigitalOcean. All these platforms offer you very simple deployments, or Heroku even. But for HIPAA compliant stuff, it's just not enough. You cannot really deploy HIPAA compliant applications there, or it costs too much. So the only options really that you can pick are Azure, AWS, and GCP. And for this video I choose Azure, so we'll be using all the Azure platform to deploy a HIPAA compliant application. So let me first show you what the application actually does. It's a document processing application, and then I will break down of which components it consists and how they connect to each other. So here is the applications. Here are some documents that I already uploaded. So let's upload a new file. I can select from here. Let's just do some stuff like, I don't know, compass. Let's upload compass. Now it will upload. And here, like, this application is really vibe coded, yes, so don't judge me. It's just to, in a sense, show the purpose. It's just a placeholder. So here I don't have proper polling, so I just need to restart it a little bit. Need to refresh. It's still processing. Let's just wait a little bit, and then I will show you the end result. As you can see, it already popped here, completed, so we can open, and it generates a summary of this document. So basically, it's a application where we can upload documents, the worker picks them up and generates a summary. And then we also can regenerate a summary. So if I click, let's just wait a little bit, and now the summary will be regenerated. Here you go. Exactly. So now let's see what it consists of. Here we have a backend that consists out of two parts, which are a worker and an API. As you have seen, worker picked the document up, processed it, like generated the first summary, and then as an API we have the stuff that regenerates the summary. Then we also have a frontend that is Next.js. So what about all the services that we will be using? It's basically Azure Web App services for deployment of the applications, Azure Container Registry for holding our container. We have also Azure Flexible Server, which is for database for Postgres. We have Azure Blob Storage, which is for document storing. We have Azure Document Intelligence for processing of the documents, and we have Azure OpenAI for generating the summaries. So as you can see here, this is exactly how it looks. Here is the front end, here is the backend, here is the backend app service in a sense. It's there. This is a private endpoints. We have the Azure, we have the blob storage, and yeah, this is basically how it is. Now, what we'll be looking into is, let's see how to actually how actually all the things are structured. So here, the whole purpose of HIPAA is that your data stays private. It's very important. So here what we will be doing is we will be closing everything up. So the backend, database, and blob storage will be completely closed from the outside world. Not a single computer from the outside will not be able to access them. And we'll be creating separate endpoints and private DNS zones in a sense that can talk to the stuff. Yeah, so let's see. Here, for example, we have the Azure Container Registry where both services, the frontend and the backend, pull the images from that we upload to just have the code and have it running there. Then we have our patients or whoever is using the tool that go inside the frontend, and frontend is obviously publicly available. That's in a sense how users interact with our application, right? And the frontend is living on a frontend subnet inside our virtual network, but is publicly accessible on the outside world for users to access it. Then, what we have is a frontend, as you have seen, uploads the document to Azure Blob Storage, and it happens via a private link. So it goes directly inside the virtual network, inside the private virtual network that is encrypted traffic that is blocked from outside world. It uploads to the blob storage, it connects to blob storage private endpoint. As you can see here, I have Azure storage account which lives outside the VNet, and this is just by default because it lives on Azure backbone, it lives on the server, and it's not inside my VNet. But what's inside my VNet is the point where we can access it. So the private endpoint is the only place where I can access it. It lives on a storage subnet, and it provides me secure access from my frontend to the Azure storage account. The same thing goes for the backend. Besides, backend is not publicly accessible at all. We have, as you can see here, we have the private endpoint for the backend, which we can access from our frontend via a private link. Then the private endpoint backend connects to backend app service, which runs on the backend subnet. Also very secure, very private, cannot be accessed from the outside world. And now the backend has access to blob storage because it needs to poll to see which new documents come into the blob storage, and it can also access the database so that it can register the new documents, and then when it's done processing it can store the summary. So it also has the access to the Postgres server that lives on the DB subnet. And you will ask me, Max, and why Azure Storage account lives outside and you can only access it via private endpoint inside the VNet, but Postgres lives directly inside the VNet and doesn't need a private endpoint? It's just two ways of how you can do it in Azure. You can either store it on the outside and have a private endpoint where you can access it, so basically it's the same thing, or you can have it directly inside your VNet, and it's very comfy and easy to set up. This is where it lives. It connects via TCP 5432 for the database. And here you can see more of, here is the stuff, private DNS zones is just kind of the private IP that is inside the VNet, yeah, because all the services have also public IP. And if I would talk, for example, from my local computer, let's say to my Postgres, I won't be able to reach it even because access from the public IP is blocked. So, and these are the private IPs that I can access through my VNet, inside my VNet, right? Now, as you can see also here, very important for HIPAA is that you keep a track of all your stuff. So you really need to store the data. I mean, you need to have the backups for the data, and you need to have very extensive logs and analytics. And something that you probably don't even know what it is Azure Bastion. So Azure Bastion lives on the Azure Bastion subnet, which is inside the YouTube VNet. Well, actually, in a sense, if I would make the graph perfect, I would put the Azure Bastion subnet here outside, and here I would put the virtual machine that I connect to from the Azure Bastion subnet. But let's imagine that it doesn't matter. Azure Bastion subnet is the stuff that is for debugging and just looking inside your application. Because what happens is that, for example, when you lock down your backend, your Postgres, your blob storage, you cannot really know what happens inside. And it's a big problem that I faced because I locked it up and then I had some issues and I couldn't really debug it because it was working perfectly on my dev, but on my prod it was not. And I didn't know how to even access the logs. Because again, it's blocked from the outside world. I just cannot connect from my private computer. So what is Azure Bastion is stuff in Azure where you can host a virtual machine that will be living inside your VNet. You give the Azure Bastion access, for example, from your IP from your computer, local computer. You access the Bastion, you get inside the VNet, and then from the VNet, you get inside the virtual machine that lives inside the VNet, and from the VNet you can interact with all the services, because again, here we have the SSH connection to the backend, we have the connection to the storage, and we have the same connection to the database. That way we can see what happens inside the backend, inside the database, inside the storage account, and debug it properly if something happens. So this is kind of the stuff where you use it for debugging or for looking into issues from your local computer, because again, you just cannot look directly into it. For frontend, you still can look it up from the Azure Bastion, or you can just look it up directly on the logs in the Azure platform, or you can even just query it from your computer via Azure CLI, because again, it's publicly available. So, without further ado, let's just dive into code a little bit. I show you the general architecture in code. We won't dive too deep into it because I will put you a link to the repository so that you can check it out and look it through yourself. But because there are some tips and tricks that I have for you, we'll discuss it right now and then already go into implementing also commands. Okay, so here we are inside the code base. Here is nothing special. This is just the config file where we have all our environment variables listed and everything set up. Then we have our database stuff. We have here the repositories, which are also kind of database actions, and we can see here we have our document model with all the fields that we have right now in our document, in our database. I use here, I think what it is, SQL Alchemy for this stuff. Then, well, if we already go throughout the user flow, in a sense, the first thing that we enter is frontend, and then we already upload to Azure Blob Storage. From Azure Blob Storage, we pick it up, and we need to check if the new document got there. Yeah, so here we have the upload stuff. We have the get blob properties with the e tag, which we use instead of the document ID. We list the blobs. We can download the blob for local processing. We can delete blob, get blob properties, find unprocessed blobs. So this is exactly the stuff that is main, because what we basically have is a worker that constantly pings the Azure Blob Storage. It compares it with my database based on e tags that come from Azure Blob Storage, and we see if the document is still not registered in the database, it means it's new, so we need to pick it up, register, and process. And mark as processed is just like to have a process state, right? Here we have the document intelligence, which we use a pre-built layout model. We just pass the document so that we can extract all the proper text and then work with it already to get the summary. Here is the summarizer, where we generate the summary based on the document content. It's very simple. So here is some generic prompt. Haven't even read it because again, this app is vibe coded. It's just a mini version of the actual app that I was building, like, I don't know, 5% out of it. And then here is our main worker, where we have the document processing worker, which, as I said, it gets the stuff out of the blob storage, processes it with the Azure Document Intelligence, and then generates a summary, saves it all to the database, and marks as complete. We download to the temp, load process documents to see, to compare, poll for new blobs to see which blobs are still unregistered, poll pending documents to see the status that is still processing, and here is the run command, right? Then this is the main. We have the course stuff, we have the default fast API initializer, document response class, and here we have our APIs. We have the health, we have the docs for uploading, we have the documents get, we have special, this is the all documents get, this is the special document get based on document ID, and we have the post to regenerate summary, which is our actual main API for summary regeneration. And now if we look inside Docker, it's very simple. We just get our requirements.txt, which you can see here, also very simple, very slick. And we do pip install, we do uninstall supervisor, don't know even why, but that's what I've been doing, and it's very useful. We copy all the stuff inside our container, we use the startup scripts that I will show you right now, and we open it all on port 8000, which is a default port for Azure. So now let's look into the startup script. Here we just see the environment variables, blah blah blah, and the main thing happens here. As I've told you, we have two parts out in our backend, which are worker and API. And normally what you would do is you would deploy worker on ACR plus ACI, which is Azure Container Registry plus Azure Container Instance, and you would deploy an API in the Azure Web App Services, which are actually built for APIs. The problem is I really couldn't get the ACR plus ACI to work. Like, I couldn't. It just didn't happen. So I decided that I will do everything in the web app because I hosted the API very easily, and I thought that now I need to just figure out how to do the worker. So we expose the worker in the background on port 8000, and we start the worker in the background. And we also have our APIs. API works without a problem because, again, we just ping, short work, and it comes back. That's done. Yeah, the Azure App Service is built for that. But now the problem is with and we will look inside the environment variables right now. Don't worry, I already erased all of this. This thing doesn't exist anymore, so don't worry. And the point is that here you can see that I have poll interval seconds 15. Why I did that and why we even have this kind of polling mechanism that I just described to you is because the Azure App Service times out really fast. It's not built for workers, again, it's built for APIs. So we need to keep constant interaction, constant traffic of data so that it doesn't go idle. And that's why we need to have this polling. In fact, we are polling two stuff. We are polling the database and the blob storage, and we compare them between each other so that it's always in the action, so that it's always pinging something, so that it stays alive and it gets the work done. So this is for the backend. Now looking in the front end, very simple API stuff. We have the API for the upload to the blob storage. Here is our document page, nothing special. Layout, general page where we demonstrated. UI is all SHATCN, regenerate summary button, upload form. Yeah, here is nothing. Here is nothing interesting, nothing to report. You can just look through it and check it out. And talking about the Docker file, well, something that you should know is that, well, you need to use legacy pure depths. Then what else? Telemetry disabled. No idea what it is, but I always put it. And then for environment variables, you need to specify them in the arguments. So in fact, you will need to, for example, in your build command, you will need to be specifying them directly. I will show you later when we will be building it all and running all the commands together. You will see what I mean by that, but you will need to do it. I have also here a startup script. We will look into it now. Chmod to make it executable. We copy all the packages, we install all the stuff, and we run it, and we expose on port 3000, which is a default Next.js port. So let's just look into the scripts. I'm actually interested what I have here. Components, hooks, lib, wait. Sorry. So yeah, here I have the script, and it's basically nothing. It just execute npm run start, and that's it. And it works perfectly. So yeah, here again in the front end, nothing special. Just keep in mind the variables and legacy pure depths, and everything will be good. Fantastic. So now in the global README, you will have it also available. I specified basically all the commands that you need to run. You can basically turn off the video and just go implement them by yourself, or stick with me and see how I implement them all. Maybe we will run into some issues that normally happens when deploying on Azure, and we will need to live debug, but let's see where it brings us. So let's just start by defining the variables. That's something that you need to always do in your workflow. We are specifying here the resource group, the location, all the VNet, all the network configurations. We specify the database, parameters, names, and blah, blah, blah. Again, you're just free to copy paste. Here we go to the app service. We need the plan and the name for the backend and frontend. Here we have our ACR and the logging data. Here we have the bastion. As I mentioned, it's for debugging and connection to your private resources. And here are our private endpoints. Bam. Okay, so now let's create the resource group in the location first. Before that, obviously, if you don't have Azure CLI installed, please figure out how to do it and install the Azure CLI. Now let's create the VNet. Okay, now let's create all the subnets. We have the frontend, backend subnet, storage subnet for Azure Blob Storage. Okay, now private endpoint subnet for the backend. Now we need to make sure that we disable the private endpoint network policies. Okay, perfect. Now we create the private endpoint for the subnet. Do the same stuff for it. Now we'll create the DB subnet and get its ID. Sorry. Perfect. And also, I hope you are keeping in mind this schema, because basically right now what we are doing, we're just setting up all the different stuff. We just set up the network itself, and now we are setting up the private endpoints front and backend, private endpoints for the whole stuff, for the blob storage, for the Azure Postgres, and sooner this whole stuff will expand and we'll see already every single stuff on this diagram implemented in code. So okay, now let's go and create Postgres. Pay attention to the plans. Here I'm using this standard. If you want, it's not the minimal one probably, so check out in the Azure so that you don't spend a lot of money, but I will be testing with this one. Took some time for a database to spin up, but let's keep going. I mean, for a flexible server to spin up. Now we're creating the actual database. Bam. The database is up. Now we are creating the storage account. Storage account is done. Now we are adding the network rules to it. Putting it on the VNet, assigning the subnet. Now we create a private DNS for the blob storage. Okay, perfect. Now we go and link the DNS to our virtual network. Perfect. Now we are getting the storage account ID, saving it in the variable, and we create the private endpoint for our storage account. Okay, as I said, not everyone is perfect, so let's debug this thing. Okay guys, so I've just fixed the issue that we got here. Basically the correct command is this one. We need to specify both the VNet name and the storage subnet name, plus the storage ID. And I just replaced it in the README, so you will have already the correct versions as this one. Now let's create the DNS zone group for the storage. Perfect. Now let's create the app plan and web apps. So let's create the plan. Also pay attention that our plans are running on Linux. So basically, for example, if you're building your containers, you will be needing to use stuff like buildx to build Linux compatible stuff for AMD processors. Sorry. So let's create the backend web app. Perfect. Now the front end. So as you can see, we have Python 11 there, Node 20 here, so depending on your setup, please adjust it. Okay, great. Now we enable the VNet interaction for the backend subnet. Great. Now we get the backend subnet ID. Now we add the VNet integration for our backend. Okay. Now we enable the VNet integration for the frontend. Great. Now we get the frontend subnet ID, so basically doing the same stuff. Got it, and now we do VNet integration for the frontend subnet. Fantastic. For me, it's already another day. For you, it's just another frame. We just did the VNet integration of the frontend app, and now we are cruising forward, and we will be doing the container registry creation. Yeah, so we are creating the ACR. Let's do it. Perfect. Now we do this one. We set up the backend identity. So let's get the backend ID. Great. And now we set up the frontend identity and get the frontend ID. So okay, and frontend ID. Now we get the ACR ID. And now we'll assign the ACR pool rights for the backend and for the frontend. What is ACR pool? Is basically ACR is somewhere where our image lives. So how we will be doing it? We will build an image on our local computer. We will push it to the ACR, and then the application needs to pull the image from the ACR so that it can spin up the process and run the code. So let's get the ACR pool rights for the frontend as well. Perfect. Now we'll enable managed identity for the backend. And do the same for the frontend. Fantastic. Now let's go to step 8. We build and push our container images. So first let's log in into our ACR. Great. Now we'll build the backend and push it. So first we'll go inside the backend directory. We'll build it because, well, you have seen in my repositories that I have two separate Docker files, one for the backend, one for the frontend. As I said earlier, you remember that we are using BuildX, and we use the Linux architecture with AMD 64 processor type. And yeah, that's something that we'll be doing now. So let's go and make it. So we do it. Okay, great. And now we'll first cd back, we do cd frontend, and in the frontend directory we build and push the image for the frontend. Same way we use the buildx build. And basically this time we are building just basic stuff, because at the end this build command, well, for backend it won't change, but for the frontend we also need to specify all the arcs of the stuff. But we will do it now in a second, because we first need to set them in the actual web app and then already rebuild with them, kind of. Okay, perfect. So we just created, we just pushed our frontend image. It took some time. I didn't show it, but it took some time. Now let's configure them. Here we are just configuring them to use this custom image. So here we are tagging it with the backend latest. It's for the backend. Here it will be the frontend latest, and we are giving them the Docker registry server URL, right? So let's do this. it worked. Let's hope that it does. Let's do the front end now. Perfect, so we did the front end update. Now let's set up the app settings. That's something that I've been talking about. So first we need the storage key. If not, we'll just copy it, but let's make sure to see echo storage key. Okay, yeah, perfect. Then it worked correctly, everything. Now look, we'll set up our backend with these configurations. So let's just walk through it. We have the Postgres host, DB user and password. We have the Azure Storage account name, container name, and account key. And we have the websites port 8000, default one, and VNet router enabled one, right? So the only thing that I see missing is the database URL. So let me just get it quickly, the command, so that we run it all correctly. Fantastic, so I adjust just a little bit, and now we have the database URL as well, which is exactly what we'll be using. Sorry, I think actually right now, well, it doesn't matter the directory, but still, let's switch to the backend, because right now I work with the backend, but actually it doesn't matter here. But I already started erasing, so let's do a cd backend, and now we construct the database URL, and we configure everything for the backend. I already described to you which values we have here. Let's go. Okay, great. Now we go to frontend, and actually no. Here we first print the whole all the values. Here are they, and this print I just put so that it's very comfortable for you, and you can just copy and you paste it in the in your environment variables. Yeah, so actually, do we have the polling? No, we don't have the polling one. So basically you can erase everything besides no, I mean, you leave your Azure key, document intelligence, you leave the Azure OpenAI key. I hope you know how to get it. And then for storage in the database that need to be kind of private, we already go and we create all this stuff. And here we just put the equal signs, and here is how it goes. Yeah, leave the poll interval as well, right? So now let's go back to the README, and let's keep cruising for the frontend app settings. So we'll configure here. Here in the frontend, we just need the blob storage to upload. We need the next public API URL, which will be our backend app, Azure websites.net, websites port, and VNet router all enabled. So let's do it. Let's echo again, put the values for the frontend. I always recommend you keeping, as you can see here, I have my env.development, env.production, and I also have the actual env, right? So it's a very nice way to separate it all. Yeah. So let's go into this, and here we just first we just do the echo for all the frontend values that we need. Bam. And we grab them. We put them in our .env. Telemetry disabled. Well, let's leave the telemetry disabled because yeah, we didn't put it here. Okay, yeah, and that's how it is. That's our front-end values that we need. Now we go back to the README. And we go to the step 11, where we set up the private endpoints for our web applications. So let's go here. Actually, again, the directory here doesn't really matter. We can even switch to the root and everything will be working fine. Fantastic. Now let's go further and let's add the private DNS link to our VNet for our backend app. Great, now let's go forward. Let's deny all the public traffic for the backend. As I told you, backend will not be able to be accessible from basically anywhere besides the allowed stuff that is inside the same VNet, like our database, blob storage. Well, they don't really communicate to backend, but backend communicates to them. but for example, frontend, because it has a subnet in our virtual network, it will be able to reach the backend. Again, just keep in mind this whole diagram, right? So frontend, PE of the backend, here is our backend, both of their subnets live inside one VNet. That's how it works. Now we'll get the backend app ID. And now we create the private endpoint for the backend application. Bam. Okay, so let's debug this. Okay, so fixed. Let me tell you what's new right now. Right now we're also just getting the P backend subnet ID. Oh, sorry, let me close the window. We are getting this and we are putting it here in the subnet. Before I think it somehow didn't grab properly, but now as you can see we ran this updated command here, yes, and it works perfectly. So let's keep cruising and let's just create the private endpoint DNS zone group. Also, I'm not showing like the whole debugging process. There is literally nothing to show. What I do is I go inside ChatGPT and start asking a bunch of questions. What could happen? Why it didn't go well? And then I just change the command, test it, and if it works, that's great. So I recommend you doing the same. If at some point in this whole flow you run into whatever issues, ChatGPT O3 is your best friend to just talk to and figure out the issues that you're having. Now let's do the same for the front end. So we get the frontend app ID, we get the P frontend subnet ID. And basically also when I was figuring out the whole deployment, like first time, also what I was doing, I was just constantly talking to different AIs, to Cloud 3.7, Sonnet Syncing, to O3, to basically everything to just figure it out and see what works. And then after a lot of time trying and erroring, I got it. So that's the motivation. You should go and ask questions if you have any. Okay, so let's go on. We just created it, and now let's create also the private endpoint group. Great. Now let's allow backend to be accessed from the frontend, right? So backend, the only way it can be accessed is inside the same VNet. Our frontend has a subnet inside the VNet. You remember the diagram. It can communicate to the backend. We already explained it 1,000 times, so that's what we do here. Now let's go to the step 12, which is basically the final step, where we really just have our Azure Bastion set up. So we will now set up the Azure Bastion, we will configure the logging, and we will also just redeploy the frontend with all the environment variables. I will put the whole command in the also here. We restart both apps, as you can see here, and we will test it out if it actually works. So let's see. Let's create the Bastion first. Actually, no, this step was fast, but I believe there is some point where Bastion actually takes a lot of time to do. And here we are just creating the public IP. So what we're creating public IP for is so that you can access it from your local computer, and then already Bastion will be having the VNet integration that can talk to your services that are blocked by the public access but are accessible within your same private virtual network, right? So now we are creating the network for the whole kind of Bastion, and then we'll enable the tunneling so that we can SSH into it. Okay, great. That actually took a while to do. So network creation for the Bastion, that's what takes a lot of time. Now let's go and enable the tunneling. Great job. Now we'll enable the logging. And then now I will get us the command to rebuild the frontend with all the arcs specified. We restart both apps and check what's up. Okay, so here is the command to build our frontend with arcs already. And we build plus push. We actually need to... Okay. Sorry, there was some parsing issue. So let's first actually log in again into the ACR. just in case we need it, in case it expired. So while we're logging in, and now we can already build these arcs and push the updated image. So let's do it. Perfect. Now look, what we're gonna do, we're gonna restart our backend application. We're gonna restart our frontend application, and we'll give it some time to propagate. I normally give around 10 to 15 minutes for it to start. And then we test it out. Hopefully it works. If not, we figure out how to make it work. And then obviously either when we will be debugging, or if everything works just after that, I will also show you how to connect to Azure Bastion and configure all the correct stuff. Perfect. So 15 minutes passed, and now let's check if it even works. So let's just open. It doesn't. Okay, so let's figure it out. Okay guys, so as you can see, we just gave the public access to the frontend so that I can reach it from my local computer. It's there, it's working. The only problem is that it doesn't communicate to the backend, and we need to see why. So probably the backend isn't starting properly, maybe there is some pooling issues, but let me show you first what I did to enable the public access. Here I have fixes. So I just check for a default action and making it allow for the frontend. I also check all the IP restrictions. I make sure that we configure it so that we don't have any deny all rules, because again, we need our frontend to be accessible from our computers. We check the public network access, and we make sure that we have public network access enabled for the frontend. After all those changes, we just restart the application, and here it is. Let's actually check if frontend can communicate to the blob store. And the problem is only in the backend part, because here I entered. I will later show you how I got here, but basically you can see the logs, and I have server-side error with fetching, and the error is timeout. So probably backend didn't start properly, didn't pull from the ACR. Something happened in that regard, right? Because here we are trying to make the call, and we kind of do it. The app started. But yeah, it doesn't seem that the call is successful somehow. And how I got here is I went to my app services. I went to YouTube frontend 2. I went to log stream, waited a little bit here, and then there is a button to diagnose and check. So let's wait for this. Let's restart. Yeah, diagnose and solve problems. Then we click application logs here. And here you can actually see all the application logs. Exactly. So this is the stuff. Or you can even go one step further. Yeah, but basically this is enough. So right now what we'll do, yeah, let's just try uploading one document. Let's just try something, right? JJJ. Okay, failed to upload document. Good. Then we have problem with the communication from the frontend to the blob storage, and we have problem with communication from the frontend to the backend. So right now we'll see what's wrong, and we'll fix it. We'll also be using Azure Bastion to help us debug the backend. So stay tuned. Okay guys, let me walk you through all the fixes that I've taken. You have already seen how I fixed the frontend to be accessible from my local computer, so that's good. Now the point was that we couldn't upload the documents from the frontend, right? And then I started working with storage account, so I will just show you all the commands that I did. I also will leave them all in the readme. Here we add the service endpoint to the frontend subnet. We allow the subnet to reach the storage account. We also allow for the backend to reach the storage account, so we give this kind of service endpoints of Microsoft Web, Microsoft Storage. We allow the backend subnet to reach the storage subnet here. We just see like if it worked. And we slam the public door on the storage account. We make the default action deny to deny all the access, but we allow it from our services, right? Then we restarted the backend app here. Okay, and here we set up our Azure Bastion to debug the backend. We determine the variables, create the network security group, assign it all the different permissions, do a sanity check. We do the private NIC for the jump host, And then here is the most important part. We deploy our virtual machine inside the VNet without any public IP access. It will be only accessible throughout the endpoint. It's in Ubuntu, right? So, and then we SSH into the virtual machine through the Azure Bastion that we created earlier. Here are the installation commands that I ran to just install the packages. Here you install like this, and then you also install the Azure CLI. Here you install the Azure CLI, and then to check the logs, this is a command. Then, as you can see here, you just log in, you select your subscription. Here were a bunch of logs, yeah, this is what I did so far. Yeah, you will see this kind of green stuff whenever you get inside the Azure Bastion. I will not be showing you all the comments with the answers because it doesn't make sense. But here are all the comments that I ran so far. But what I noticed that is very bad and very weird is that our storage actually doesn't have a container. Somehow it didn't get created. So instead of searching for the command, I just really want to create it myself. So I'll just go directly into storage account and I will create it manually like this. I just click create. Perfect. The container is created. And now let's basically try again our uploads. Let's see if it works. Let's just select some random stuff. A. Perfect. Finally, the document upload works. Now let's see if the backend processes it even. So we go to the dashboard. Something is wrong here. Let's see. I think we still have some backend issues, but at least now we can upload from the frontend. So connection between frontend and the storage account is good. So now let's see what we can find about our backend. Okay guys, I think I found the issue. I remembered how I did it last time. So here we had PostgreSQL, and actually we need to have just Postgres. So let's just go to our app, to the backend. Let's go to environment variables, this, and we change it to here. Up. Now we need to rebuild. Yeah, I think we need to rebuild. We'll need to rebuild. So we do exit here, and then we do our build command for the backend again. Here. We do cd backend, we build and push. Actually, wait, no, stop. First we need to log in, because the push will be denied because of the access. Then we need to rebuild it, because now we change the environment variable. And after that we need to restart, wait a little bit, and supposedly it will work. So it actually finished already. Okay, sounds cool. Then let's just restart the app from here on. Let's wait like 10 minutes and check it out. I hope that it will work. Okay, so the issue with the backend is found, and it's just the naming of the database URL. It's just crazy. You need to be very, very attentive when you're doing all this stuff, because just like here I missed the 2 and it already couldn't connect. So we just apply the change. We restart the application. I'll wait 10 minutes and see if we get what we need. But supposedly now it will work. Let's see. So finally, guys, everything worked. Before I told you that we don't need SQL in the Postgres ending, that we just need Postgres, but no, it actually this SQL alchemy requires SQL here at the end, so it's very important. SQL here and to here. So I configured it. I went here, went to the environment variables, I configured to have SQL and to have the two, and it resolved the database issue. So it was just literally the naming, probably because I already just got too tired deploying it all. And now we can see the documents that we uploaded. It got processed perfectly. Let's actually just let's get in the Bastion, and let's spin up the logs and just upload one document, see how it gets processed. So let's go like this. Let's define the variables, resource group, let's define the backend app, and now let's call the logs. Let's just wait a little so that we can see how it scans. Yeah, so right now everything looks good to me. No blobs found, no new blobs found. Now, yeah, here is how it all checks. Yeah, so it just checks, says no new blobs found. Now let's actually upload document. Let's select something. Let's go, for example, this document. Don't know what it is. Some research paper. We uploaded. Now we have the document successfully uploaded. And here, if we go, you remember here I don't have the proper pinging, so we will need to refresh a little bit. Here it still didn't find it. API documents. Okay, I think it found it. Yes, so now it's processing. We are doing the, here it goes the Azure Document Intelligence. We extracted the text, and now we marked blob as processed, so it got properly processed. So now we should see a summary. Perfect, it works. Now let's see if the API works. I really hope so. Let's see. Perfect, as you have seen, it just changed. So the API also works. Finally, we got deployed. It took me still a lot of hours because, again, every time I write down my comments and say, and now it will go perfectly, now it never goes perfect. So really have some patience for your application, but I will put all the commands that I ran so far in the README. Please pay like huge attention to the naming. It's very, very, very important. And yeah, that's basically a HIPAA compliant deployment of the full stack application. We had Python backend with Worker and an API. We had frontend with Next.js. We used here Azure Document Intelligence, OpenAI. We used SQL Alchemy for database stuff in Python. We used blob storage and Azure on Postgres, as well as Azure Web Services, web app service to deploy our applications, plus Azure ACR. So if you watched it until that point, basically you are now the master of Azure. I really encourage you to go either just clone the repository and deploy this same application to just see how it feels on your own pace, or take your own application that is a similar build and try to deploy it using the scripts that I just gave you. To sum up, hopefully right now you understand the whole diagram very well, and I hope you learned something. If so, please hit the like button, subscribe to the channel, and share it with your friends. Have a great day, guys. Bye bye.